Hello everyone. In this video, we're going to be solving an exponential equation, a very exponential equation. We have 1 over x to the power x equals 4 to the power x plus 1 over 16. By the way, this is a homemade equation, and we've done a similar problem before. I'll share with you, hopefully, if I don't forget, remind me if I do. Anyways, so let's go ahead and solve this equation. How do we solve it, right? It kind of looks complicated. First of all, what is the meaning of 1 over x to the power x, right? Well, we can write it as 1 over x to the power x because a over b to the power n can be written as a to the n over b to the n. But when you have 1 over b to the n, that is just 1 to the n, b to the n. But 1 to the power n is 1, so it can be written as 1 over b to the power n. So we don't have to worry about the numerator, we only have to worry about the denominator. Great. Let's go ahead and split these up into a product, 4 to the x times 4 to the power 1 over 16. So I'm going to go ahead and present the solution method, and then we're going to take a look at the graph of some functions. Okay, great. Let's go ahead and simplify this a little bit more, or manipulate it. I want to multiply both sides by x to the power x. I want to get rid of all the fractions. So we get x to the x times 4 to the x times 4 to the power 1 over 16 equals 1. Great. Now let's go ahead and put the two terms or factors together that have the same exponent. That kind of makes sense, right? I mean, these two terms are kind of sharing the exponent, so we can kind of put them together. So it's kind of like the formula a to the n, b to the n, and we can write it as ab to the power n. Make sense? So we can write this as 4x to the power x. And what am I going to do with 4 to the power 1 over 16? Let's divide both sides by that, so I can write it as 1 over 4 to the power 1 over 16. So this kind of puts the x's together as much as possible, right? And the number on the other side. So it's kind of like something you would want to do. All right, great. So what should I do with this? 4 to the power 1 over 16, but that's reversed. So we can write it as 4 to the power negative 1 over 16. So negative exponent indicates that it's the reciprocal of something with a positive exponent. Make sense? Great. So now we're going to manipulate this a little bit more, but let's rewrite the final equation. So I got the following. Now you might be thinking, hey, we have the same base, but we don't. The base is 4x. Here the base is 4, but on the other side it's 4x. They're different. So we can't just equate them or set them equal, but we can do the following. We can at least make the base and the exponent the same on the left-hand side. So I'm talking about something like a to the power a. How? Wouldn't it be nice if we had 4x as our exponent? So that means we should raise both sides to the 4th power, because that's going to give you what you're looking for. Maybe you weren't looking for that, but I was looking for that. So now we have x times 4, which is 4x. Beautiful. That gives us 4x to the power 4x. And here we have to multiply the exponent. So that's going to be 4 to the power negative 4 over 16, which can be written as 4 to the power negative 1 over 4. This is cool, but not cool enough. So let's cool it down a little bit more. How? Well, on the left-hand side, we got something like a to the power a, but we didn't get the same thing on the right-hand side, right? So we're looking for something like this, like if a to the power a is b to the power b, then we can conclude a equals b. For, at least that's one of the solutions. Okay, now, here's what we're going to do then. 4 to the power negative exponent. So can't I write that as 1 over 4 to the power 1 over 4? Absolutely. And by the rule we talked about, this can be written as follows. Now remember, 1 over b to the n is the same as 1 over b to the power n. So we can write this as, this number, as 1 over 4 to the power 1 over 4, because that's what it is by this rule. Make sense? Beautiful. Now we got the one-to-one correspondence. What is it? 4x is 1 over 4, and 4x is 1 over 4. Isn't that great? Yes, and now we got 4x equals 1 over 4, and then x equals 1 over 16, and case closed. This brings us to the end of, wait a minute, this is not the end of the video, because we got another solution. Wait a minute, how do you know that? Here is how. 1 over 4 to the power 1 over 4 is a very interesting number because 1 over 4 is 1/2 squared. So what is so interesting about it, right? Well, take a look. If I write the 1/4 as 1/2 squared and then multiply the exponents, I get 1/2 to the power 2/4, which is 1/2. Wow, that's really cool, isn't it? Look, what we got from something like a to the a, we got something else like b to the b. So that's important because now if you take this variable and then set it equal to this new thing, now we can say that, hey, 4x equals 1/2 satisfies this equation, not just 4x equals 1/4, right? So what is that supposed to mean? It means we have two solutions. Do we only have two solutions? We're going to take a look at the graph and we'll talk about it. But this gives us at least x equals 1 over 8 as another solution. So this equation looks like at least two solutions. It has at least two solutions. What is the original equation? This one. Yeah, it looks complicated, but remember, after all these manipulations, it looks much nicer, don't you think? Take a look at this one. Beautiful, right? Now, we got two solutions, 1 over 16 and 1 over 8. Let's go ahead and take a look at the graph. So, here's the graph of two functions. First of all, I made a graph like this, but notice that there are two intersection points. You don't see the points, but I'll show you on the next graph. Here we go. I graphed 1 over x to the power x and 4 to the power x plus 1 over 16. So those are the left-hand side and the right-hand side of our equation. And notice that these are the x values. And because of the way they curve, and you can kind of see the curve better here, notice that one of them is kind of concave up, the other one is concave down, and they intersect at 2 points only. There's no way they're going to intersect at other points because they're just going to get away from each other. And notice that the blue graph, is that green or blue? I think it's blue. The blue graph starts at 0, so it's only defined for positive numbers. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.